Okay, so folks, in later pre-works, we'll look at techniques for factoring trinomials like the one that we were just studying in the previous video. But before we do that, I want to review a skill called factoring out the greatest common factor, GCF. So that's for greatest common factor. Rather than explain this technique, which could actually be a little lengthy to try to explain, I'll just demonstrate it in a series of examples and then ask you to try to mimic it. So folks, for each one of these, I'll work a problem, and then I'll ask you to pause the video and then work its pair on the opposite side. So in this case, what we would identify is the greatest common factor. The largest factor for that both of these terms have in common is 3x to the fourth. What I mean by that is that embedded in this factor right here are the factors 3 and then 4 powers of x. There's actually one more power of x, but that won't help us when we look at this second term. Looking at this second term, we also have a factor of 3 and 4 powers of x. So we don't need to do this. Usually I won't, but for this very first example, I'll just show you a little bit better how this works in terms of powers, because we haven't reviewed exponentials very well in this class yet. So if I were to write this term out, it'd be 3 times x times x times x times x times x multiplied to itself 5 times. And if I were to write out this term, we'd have x times x times x times x. So if I ask you, now that I've written it in terms of prime factors, what do both share in common? They both share those factors in common, where this term has an extra factor of x. Now folks, usually you don't have to do this, and instead what I'm going to ask you to do is just go ahead and factor out that GCF. You've probably done this before, so let's go ahead and do it now. So I'm just going to go ahead and write that 3x to the fifth minus 3x to the fourth, why that is equal to, and pulling out the greatest common factor, would be 3x to the fourth times x minus 1. Now, what you should always do for these problems is confirm, whenever you pull out the greatest common factor, I see students make mistakes all the time, even though they understand the process, is you should confirm that if you were to distribute this factor to both terms in the second factor, if you were to apply the distributive property, notice that you get back to the original expression. Okay, so I'd like you to pause the video and try this problem. So pause it, and then we'll talk about it. So giving this a shot, folks, what you should have done is identified the greatest common factor here. In this case is the factor 7x. And so we would write 7x squared minus 7x is equal to 7x times x minus 1. And you should notice that if you were to FOIL or expand or distribute this 7x back through, we'd be back to the line before it. And so here we've accomplished our goal of factoring this particular polynomial. Okay, let me do another one. Let's look at this expression right here. Here in this case, our greatest common factor would be, both of these have factors of 3, and both of them have factors of x squared. And so we could rewrite this. We could say that 27x to the fifth minus 3x squared is equal to 3x squared times 27x to the fifth minus 1. And you should notice if you were to distribute this back through, you'd get back to the line above it. Okay, folks, so what I'd like you to do is pause the video, and it's really important that you actually pause the video and try this. Pause the video, give it a shot, and then I'll show you the answer in a few seconds. But please pause the video and actually try it. So folks, in this problem I found that the greatest common factor here was 8x, meaning that 8 divides into both. 8 is a factor of both of these terms. Another way to say that is 8 nicely divides into both of those terms, and so does x. Okay. Notice in this case, x squared is not a factor of both terms, even though it's a factor of this first term. So when we go to put this into factored form, we'd have 8x squared minus 64x. We pulled out the greatest common factor, and that leaves us with 8x times x minus 8. And again, you should verify that if you were to distribute this back through, you get back to the line above it. Okay, so I'll do one more here. This case we have a trinomial. There's really nothing different. It's just that we look at each of the terms and ask what's in common. And in this case, all I see that each of these terms have in common is the factor 2. The greatest common factor here is the factor 2. So if I were to rewrite the original expression, 2x squared minus 16x plus 2, if I were to divide out the greatest common factor, that would be 2 times x squared minus 8x plus 1. And you can check if you distribute this back through that you have indeed pulled out that greatest common factor. So I'll leave you to try the try for this one on your own. I'm not going to show you the answer for it, so pause the video and give it a shot. Okay, folks, hopefully you tried this problem, and I will go ahead and pause this video here or stop this video here, and we will pick up just some lingering topics in the next video. See you there.